Veronica.
Nope.
So we got Veronica online, Declan online, Alexis online, Lucas online. Alrighty, y'all. Let me unfreeze my board. Let me turn off the light.
Hello?
Yesterday, he did one-step moles. The big difference though yesterday was you had to balance it right. I actually just got caught up with grading with this class. I've graded the mole range. Jimmy, you were the one that turned in the extra credit, right? So he's not here. Was he the one that turned in the test points?
Yeah, I think so. Yeah.
Just the name on it. We are taking the new conversion factor that you guys learned yesterday, which is going between two different substances from a balanced equation. And we're going to be linking up molar masses of a starting substance and an ending substance. So technically, it's not a new conversion factor, it's just a new way to link stuff together. So since you have to be able to do molar mass for the rest of chemistry, just because that's the way it is, I'm not necessarily wanting to know the balanced numbers here, because that's not what's necessary. That's not what the question's asking. The question's asking what are the masses of the substances. So iron, well, first of all, what do you have to look at for masses? Periodic table. Okay, iron doesn't have a subscript. So when I find it on the periodic table, 55.845, it's going to round up to 55.85, but there's one of them. So if I'm doing a molar mass problem and either my starting substance is iron or my ending substance was iron for grams, then I have to do this for iron. Once again, you only use this if you have grams. If it talks about mass. Oxygen, you should know that one off the top of your head. There's two oxygens in oxygen gas, each is 16. 1 mole of oxygen gas will weigh 32 grams. My allergies are going crazy. I feel like I have sand in my eyes. Oh. And then the rest, this is the same balanced equation that we looked at yesterday. This was essentially number one on yesterday's paper. We just were talking about mass. We were talking about moles. Look for the rest for the iron trioxide, which is a technical term. There are two irons. Each one's 55.85. There are 3 oxygens. Each one is 16. Now you can do this the long way, okay, and do Fe is 2 times the 55.85, and then under it, you can do the 3 times 16. There's no reason why you can't just do it in a chain like this. And this is the way, oh my gosh, my nose. This is the way that I normally throw it in the calculator. And the total of both of these compounds multiplied out by their subscript is 159.70 grams. So this is not new. It's not. You just have to figure out what compounds are these mass, which if you're going from grams of one substance to grams of a different substance, it is a 3-step conversion factor. Please don't be scared. It's 2 of these. It's 2 of these. And the balanced equation numbers, which is what we did yesterday. I went ahead and gave you the balanced equations on today's assignment. Now, tomorrow is a work day, and it's one of those where I give you the answers. So you know that you're doing it right. You just have to show all the work. If I was going between grams of 2 different things, I would need to balance this. And if you still need to work it out on paper, great, do it. Some of you will have to do the math. Like, that's just the only way you can balance. I don't do that way. I also know that oxygen is the royal pain in the butt. So I have 2 on the left and 3 on the right. The common number that they share is 6. So I would do 2 times rust. I should have my numbers on here somewhere. 2 times rust, which means I now have 4 irons, not 2. Okay? And so I need to fix the fact that I need 6 oxygens over here. And now instead of 2, I need 4 irons. And 4 times 1 is 4. And, oh, that's supposed to be a 3, not a 1. That is a typo. I think this was the thing that I did wrong yesterday, too. It's supposed to be a 3. No. I didn't have enough time to check my check all my stuff because I was busy trying to get your grades in your parent portal and just grading stuff in general. This particular assignment does not have the answers on it, but should all have the equations balanced for you already. Because I noticed when I was grading, and if there's not a number, like this barium phosphate, it's a 1. If everything else is balanced. We go through that when we go through the notes. This one's really, really short, but it doesn't have the answers. Tomorrow's is a little longer. It's not insane. It's just I give you all the space to work it out. So it's this is the notes and this is the assignment. All right, mass calculations. You eventually, hopefully, will learn that these follow the same template. If it's from the grams of one thing to grams of something else, you have to use the molar mass, okay, of your starting substance in essentially a 1-step for moles. And then what we did yesterday, you switch from moles of the starting to moles of what you're trying to get it to, balanced equation. And then you're going to go using the molar mass of what you're changing it into, where the mole gets a 1 and then the gram gets whatever the periodic table says. You just rinse and repeat. You have to be able to do molar mass. You have to be able to pull coefficients from a balanced equation. Now, if I ask you to go from moles of one substance to grams of something else, then it's only a 2-step. And we'll show you how to use both of them today. So, grams of 2 different things is a 3-step conversion. First base, so it would look like this. Where we're going to go from grams to moles to moles of something else, and then moles to grams of what you're switching it into. But you're going to see this. Oh, wrong thing. Gram. I'm not holding it. Grams. I don't know what the compound is yet. These are ones. This is balanced equation, periodic table. This is how much you're starting with. Same thing, over and over and over and over and over and over. So tomorrow is a work day, so if you're a little confused, hopefully we can fix it. The remote day is Friday, and that's where I'm going to show you, attempt to remotely show you guys how to calculate a limiting reagent. If you're confused, it's fine. We'll have a work day next week. Oh, okay. I don't even remember what I had you filling out. Oh, that's right. You guys basically just have the things, and I'm giving you extra insider information that they did not put on your notes. Because every teacher teaches chemistry just slightly different. And so, molar mass. Don't go away, periodic table, balanced equation. Just a matter of figuring out where to put them. I'm going to put over here on the board. You're really welcome to either put this on the back or up at the top. This template, if it is a mass, I was always taught your starting substance is called the given. You may have called it a known or a provided, but you're going to start in grams. And you're going to drop grams of your given substance. That's what the capital G stands for. It could be water, it could be oxygen gas, I don't know. It could be salt. And you're going to go to 1 mole of that substance. Grams of the starting to 1 mole of the starting. G just is whatever the provided the starting substance is. You don't want to be in moles. You're going to drop moles of whatever that starting substance is. This is where people get stuck. This is what we did yesterday. What you're changing it into is the unknown, which you're solving for. I can't tell you that a 1 is going to go there, unless it's a coefficient that's a 1. And then you're going to go from 1 mole of the unknown substance to grams of that unknown substance. Periodic table calculation, periodic table calculation. This is going to be the balanced equation. And like I said, those two are going to be a 1. Mole gets a 1 if you're in the same substance. The mole does not always get a 1 if you're going between different substances. That's the balanced equation coefficient. And then where the gram is, you just use periodic table. Multiply anything on the top, divide by anything on the bottom. If you're dividing by more than one thing, you need to use parentheses. Or if you want to do it the long way, multiply out the top, write the answer, multiply out the bottom, write the answer, and then top divided by bottom. But this is not on your paper. It's just the way that this template doesn't do you wrong. You just have to figure out this bit. Then use calculator. You check online one more time and take official attendance. The notes are actually fairly short. To be honest with you, it's working the problem. Let me check online. I need to turn this off. This thing is making my, I'm sure the whole right side of my face is red from that heater. Okay, I don't see anybody else new. All right, y'all ready to work a problem? No! I gotta take attendance in person anyways. George is here. He's not here. Bailey's here. Luke. Tiffany. Sahara, Sebastian. Caitlin's here. Logan's here. Jared. Mia. And Tatiana. Reading no. Yes. Robert. No. Reagan, yes. Slate, yes. Braden's not here. Braden's absent. Jimmy's absent. Okay. Are you ready now? Are you still copying down the template? Like I said, it's not on your notes, but this is what we're going to be following. The only catch would be if we weren't going between grams of different substances and maybe we were going from grams of one thing to moles of something else, then I would stop here. You're just figuring out what you're starting with, and then you're going to keep linking together our little conversion factors until you get to whatever the heck it's asking you to solve for. All right, problems. I don't think I made any boo-boos putting this in. I already caught one in the opener. How many moles of carbon dioxide can be produced from the reaction of 250.0 grams just for sig figs of oxygen with an excess of acetylene gas? And then we have the already balanced equation. This is very much leading into what I'm going to have you do on Friday. You're going to see the phrase "and with an excess of." If something is in excess, it's not going to be part of your math. On Friday, you have to figure out which one runs out first, which is limiting. That's what controls your reaction. And which one you have an excess of, you have more than what you need. The reaction's not going to stop if you have something that's in excess. The limiting reagent or reactant, that's the important one in this class. And so I'm sort of jumping the gun to Friday. Already balanced. There are no missing numbers. Like I said, sometimes depending on the prof or the teacher, they don't put a number on there. It's representative of one. But I know, starting with oxygen gas, okay, I'm going to have to calculate its mass. Getting to carbon dioxide gas in grams, I'm going to need its mass. And I did carbon dioxide first. One carbon, each one's 12.01. Two oxygens, each one's 16. So wherever I have grams of CO2 to 1 mole of CO2, I'm going to use 44.01. Oxygen gas, 2 times 16 is 32. So wherever I'm converting between moles and grams of oxygen, the mole gets a 1, and then the oxygen gram gets a 32. When I switch between the two substances, I'm either using the 5 or I'm using the 4, because the other things are not part of the problem. Just a matter of dropping everything where it belongs. Easy part's what you're starting with. I'm going to wait because I know you can't write and listen at the same time. That's all I did, is I put my starting substance in that starting block, that top left-hand block. The little G's, they just mean gas. That's all. Little S would be a solid, a little L would be a liquid. An AQ means it's aqueous, which is normally used with an acid or a base. Looks like water, but don't drink it because it's not water. Right, before we start dropping everything else in here, is there a question how I got either one of these two masses? Yeah. Why did I have to do this? Because it's starting in grams of something. Grams is automatically periodic table calculation. So I needed to calculate the oxygen gas, oxygen's O2, going to grams of carbon dioxide gas. So I needed to calculate the mass of carbon dioxide, the CO2. You do not need to do any of this unless it's talking about their masses, which is in grams. And the reason why I have to have a balanced equation is these are not the same substance. And these numbers are how I switch in between them. So I'm starting with 250 grams. Can be produced. That's grams of carbon dioxide gas should be up here. We're starting from oxygen gas. We're switching into carbon dioxide gas. It's okay. So I don't want to be in grams of oxygen. So the very first thing you should do, I don't care what you're starting with, not the number, but its unit, go ahead and drop it. One over and down. And if you want to do the factor method that way instead, you can. Now, in grams of oxygen, Jared, pay attention. In grams of oxygen, the only thing I can switch it to is moles of oxygen. Jared, I need a rubber band gun or a Nerf gun. Pay attention. Put that away. So I always do numbers last, but if I'm in grams, I can go to moles of any substance by using periodic table. Now, I don't want to be in moles of oxygen gas. I want to be eventually in grams of carbon dioxide gas, but I don't have a way to go from moles of oxygen gas to grams directly. What I can do is I can use my balanced equation where I need 5 oxygens for every 4 carbon dioxides, and that's what yesterday's workday was for. And most of you, I had a couple people that didn't balance the equation right, and so that's why you got it wrong. Looks like some of you, maybe you didn't push it in the calculator the right way, like you multiplied and you should have divided. Some of you were doing the wrong compound, like you were flipping them upside down, but most of you were doing okay. I don't want to be in moles of carbon dioxide gas. I want to be in grams of carbon dioxide gas. I know those of you that are remote can't see me pointing, but I do have my trusty little spotlight thing here. So grams, right here, grams to moles of oxygen gas is this one. Okay, the balanced equation, that's what I'm going to use for carbon dioxide. That's what I'm going to use for oxygen. And then this is the molar mass of carbon dioxide, which was the first one that I calculated. When you're going between moles and grams of a substance, the mole gets a 1. You just have to calculate the whatever it is that goes with the gram. I bet you I did the molar mass of carbon dioxide second. I did. 1 mole of carbon dioxide gas is 44.01 grams. The part that my students as a whole, where they get stuck in all the years I've taught chemistry, is they don't know how to go in between the different substances. In the balanced equation, oxygen is a 5 and carbon dioxide is a 4. Hopefully I didn't put this in the calculator wrong, because I do that. 250 times 4 times 44.01. I'm going to do divided by open parentheses 32 times 5. And I round it for 4 significant digits. So grams will be gone, moles of oxygen will be gone, moles of carbon dioxide will be gone. You don't need to worry about putting in the number 1. You multiply the top and you divide by things on the bottom. And 275.0625 for 4 numbers, which would be 1 after the decimal in this case. 275.1. But now I'm in grams of carbon dioxide gas.
Why is the bottom big one?
4 for carbon dioxide, 5 for oxygen gas. comes from the balanced equation. That is where, like I've said, in all the years I've taught, once we start doing big multi-steps like this, that's where students get stuck. And we'll be doing 3-step masses when we do limiting reagents. We will be doing 3-step masses when we do percent yield, which will be next week, should be Monday.
Why is the first one one?
Because when you go between moles of a substance and its grams, the mole does get a 1 and the gram gets what you calculate from the periodic table. Here, they would only get a 1 if that was the coefficient up top. Here, I'm going between carbon dioxide, moles and grams, where the mole gets a 1. When eventually we do the conversion with volume of a gas,
It's like when we just go from mole and then it's another mole and
that's the balanced equation. Okay? This is just one of those that it eventually it will click, and it's the same thing over and over and over and over. You have to be able to use the periodic table, and you may have to be able to balance the equation. They're already balanced for you. I think they balanced when you said. Yes, no. Yes, this is the assignment. They're already balanced. I went back and put ones in my notes, but I did not change the paper copy and put ones in front of them. Is there a different question how I put this guy together, or possibly you're not getting the answer in a calculator? All right, next one then. Now, I mean, obviously this is not a 3-step because I already put the stoichiometry cross on here, but I'm starting in 10 moles of water. I'm trying to get from moles of water to grams of oxygen. So same equation. And I don't need grams of water. I'm already in moles of water. So I'm cutting out this step. I'm essentially starting here, but I have to use that number instead of the 1. I'm going to grams of oxygen gas. So 1 mole of oxygen gas is 32 grams, 2 times 16 is 32. And then I went ahead and wrote my mole ratio. It's just the coefficient. So the 5 is in front of the oxygen and the 2 is in front of the water. So those are the only 2 numbers that I'm going to use to switch between moles of different substances. Once again, don't have to calculate the mass of water because it doesn't talk about the mass of water. Just cuts out a step. Wait and let you guys catch up. This goes here. Are y'all ready? All right. I don't want to be in moles of water. So I'm going to leave the 10 behind, but I'm going to put the unit, moles of water, 1 over and down. Once again, this is where my students get stuck. This is where we're switching from water to oxygen. I can't go directly to grams, but I can go to moles by using the coefficients in front of them. Don't need the acetylene in here. And I don't need the carbon dioxide in this one because the problem doesn't talk about it, whether you're starting with it or you're trying to end up as that is your answer. And I'm going to bring down moles of oxygen because I don't want to be in moles of oxygen. I want to be in grams for oxygen. Where my middle part are the coefficients, where there's a 5 in front of the oxygen and there's a 2 in front of the water. And then on the right-hand side, when you go between moles and grams of the same substance, the mole will get a 1 every single time. Not here, here. And then 2 times 16 is 32 grams. Like I said, I personally like stoichiometry. It lets you check yourself. All the units will cancel. We can ignore all of the number ones. I was taught to reduce. I'm not trying to confuse anybody. If you want to divide the 2 into the 32, you can. You don't have to. But you should do 10 times 5 times 32. I'm only dividing by 2, so I don't need parentheses. Let's make sure I did not put a wrong answer on the board. 10 times 5 times 32, all divided by 2. I get 800 even. Even. So I know with sig figs, 10.0 has 3 numbers in it. If you really want to be picky about having these zeros count, you put a decimal behind it, but you don't put a 0 after that because then it has 4. I personally do not try to trick my students with floating decimals. I don't know who's doing the test. I don't know exactly what would be on your test. It should be not this Friday, next Friday. But we should, if I have to cut a workday out, if we have a hard time with limiting reagents, I have 1 day of play next week. That limiting reagents should be this Friday. Percent yield should be Monday. Should be able to make sure none of you have a problem mathematically Wednesday. Should be able to review the test Thursday, and then your test will be Friday. My only concern is if I need to cut out a workday and go back over limiting reagents. Are there questions on this one? Once again, this wasn't a 3-step because I wasn't starting in grams and I could cut that part off. I was already starting here. And you're gonna notice that I'm gonna leave this bottom left-hand box empty. If you have to put a 1 there, you're more than welcome to. I normally leave it off. It's not a hole for the answer. Y'all ready? Anybody still writing this down? Okay. Next one. Eventually, if you have a practicing how they're linking up as we go through them, I think this is the last one that's on the notes. Same equation. Once it sort of snaps into place, it's just putting stuff where it belongs. We're going to eventually get to grams of acetylene gas, that's the C2H2. We're starting off with 75 grams of carbon dioxide, so that means I need the mass of carbon dioxide, which is 44.01. We'd already calculated this like 2 problems up. We're going to need to do the mass of the acetylene gas, 2 times 12.01 plus 2 times 1.01. That's 26.04. I just did it for you. And I'm going to need the mole conversion going between acetylene gas, which will get a 2, and carbon dioxide, which will get a 4. I don't remember if I put that on there. I did. You just have to drop everything in the right block. My starting substance is 75.0 grams of carbon dioxide. My answer is going to end up having 3 numbers in it once I'm done. I'm going to immediately drop grams of carbon dioxide. And from grams of a substance, the only thing I can change it into is its mole, where the mole would get a 1. I'll just do my numbers last. Okay, I am not in my right unit. I want to get to grams of the C2H2. So I'm going to bring moles of carbon dioxide down. This is where students get stuck. This is where you switch into the other substance using the balanced equation. I am still not at the right thing, so I'm going to bring down its unit, moles of acetylene. And I do have a way to get to grams of acetylene gas. You're linking things diagonally and converting. And if you're not there yet, you're linking things diagonally and you're converting until the unit that you want all by itself, at least in the case of normal stoichiometry, is just that top right-hand unit. It does get a little bit more complicated in college. I don't know how many of you are going to take Chem 101 and 102 in college. So 1 mole carbon dioxide is 44.01 grams. 2 things, Jared. Turn that crap off and put your mask up. Okay, up here, the acetylene gets a 2, and the carbon dioxide gets a 4. And then the hole on the right is the molar mass of acetylene gas, where the mole gets a 1, and then the gram gets the 26.04. You can cross out the grams and the moles of carbon dioxide and the moles of acetylene and say bye-bye to the 1s. This would be a situation if you're putting in the calculator in one big step, you need parentheses. So 75 times 2 times 26.04 divided by open parentheses, but you have to turn your phone to the side to get the parentheses with most phones. 44.01 times 4, close parentheses, and excuse me, hit enter. This is I need it to rain. With 3 sig figs, I have 22.18813,906. So good, I didn't make a boo-boo. Rounds to 22.2. Now we're in grams of acetylene gas. If you're starting in grams of one thing and you're going to moles of something else, then you wouldn't do this last block. If you're starting in moles of one thing and you're going to grams of something else, then you wouldn't be starting, you would get rid of these. And this would be whatever the starting number they give you in the problem. But if you're going from grams of one substance into grams of a totally different substance, it is this format every single time. You just have to be able to calculate the molar masses of the starting and ending substances. All right, lucky. I think that's the last slide. I forgot to print off my notes before you guys showed up. Yes, that's tomorrow's opener. So let me stop this and let me stop this. Oh, I didn't mean to do that. I'm sorry, my remote students. I'll put that back up in just a second.